for today's warm-up, we're going to get some answers first, and then we're going to discuss a little bit. So, number one, what did you get for the values of x and y? We got 1, 2 confident people, 3 confident people, 4, 5. We'll start with Alyssa, Michaela, Sebastian. What'd you get? Okay, what'd you get? Okay, what'd you get?
Same thing as Alyssa.
Which was what?
X equals 6 and y equals 11.
Okay, x equals 6, y equals 11. Number 2, what did you get? Start with Zabari, Brian, and then Brandon. Zabari, what'd you get?
X equals 9.5 and y equals 3.5. X equals 9.5 and y equals 3.5.
Okay. Yeah, we get x equals 9.5 and y equals 3.5. We are almost to the point where we are supposed to have a whole bunch of basic ideas stored in our brain that can be accessed at any moment that guide us on what is going on in a particular picture. There were a whole bunch of different ideas that you were supposed to instantly know were needed for this. Could someone tell me one idea that you needed to know to make this work? One idea. Davis?
Supplement and complement
Okay, supplement, what does that mean?
means that the two angles add up to 180 degrees.
Good. Brandon? Vertical angles. What's vertical angles? They have the same, I didn't hear what you said. Okay, what's another word for same? Congruent, very good. So you need to know the word congruent. You need to know supplementary angles. You need to know vertical angles. What about this? We draw this in right here. What did you have to know about that right there? What is that called? Hopefully you can see it. What is that called? It's a simple question. Kayla? Straight angle. I love the way you describe that. And a straight angle is 180 degrees. So for my average high-level student, what you should have focused in on was that. And what did you do with those two pieces of information, those two expressions? Jada? You add them together and set them equal to 180 because she knew that a straight angle, as Kayla just pointed out, was 180 degrees. So we get the value of 6. So we know now that x is 6. But how do we get the y from there? Catalina?
Since Berlin said how the angles do it, I equal.
Well, what word did he use? Because you have to know it, and this is where I'm going to start becoming a bit of a tyrant. You have to know off the top of your head what these things are called. Okay, Brandon will remind us. What was the one you pointed out? Vertical angle. So it's good that you knew what it meant, but you have to know the name. So they're called what? Good. Which two are vertical angles?
Yeah, that one and the y, 11.
Good. So this and this are a pair of vertical angles because when two lines intersect, the angles on opposite sides are called vertical angles, and they are congruent. So now, Catalina, finish your thought process. I apologize.
And so I put them equal to each other and then plug 6 in for
Very good. You plug in a 6 right here. 20 times 6 is 120, and 24 is 144 minus 23. So that comes out to what? 121. So now you've got 11y equals 121. That's a one-step equation that gets you 11. So you had to understand straight angle, 180, supplementary. These add up to 180. Then you had to understand vertical angles and set this equal to this, and you had to take this value and plug it in so that you had this simple equation. Comments, questions, concerns? Anyone do it differently and have success? Alyssa?
I did 12x minus 13 plus 11y equals 180.
Okay, but then you end up with two variables. 12x minus 13 plus 11y equals 180. How did you reconcile the fact that there's an x and a y and you can't solve for one of them?
I just plugged in the x and then
Oh, so you had solved the other one already. You already had the 6, and then you used this to find out what the y was. Very good. Outstanding. Excellent job. And so she used, again, straight angle, but this time she used this line and the fact that that is going to be 180 degrees. Add them together. Nicely done. Anyone do anything different? Still have success? Okay, and number 2 was similar approach. Okay, any comments, questions on today's warm-up? Good, we're doing well so far. Today, you're going to be laying the foundation for working with more complex ideas around the idea of a polygon. So, our objectives today are to classify polygons by their sides and angles, and we're going to be using some ideas to find measures of angles. I put in that we are going to be doing exterior angles, but that was a mistake. We will not be touching exterior angles yet. So I apologize for that. So those are our overall objectives. Got a lot of terminology. So we've got some major terms here that you will become fluent in. And honestly, I expect you to be able to speak them by the end of today. And in fact, there's 2 that are missing that we didn't really touch on last year. We've got equilateral. That you probably know already. But then there's another term, equiangular. And you have to be able to say both of them and explain what they mean and utilize the ideas. And I'll be honest with you, when I say equiangular, I have to pause to make sure I say it right. Equiangular. It doesn't flow as easily as equilateral. Okay? Any comments, questions so far? So let's jump in and start talking about polygons and what they are. Remember the rule about note-taking and ideas. You copy what you feel like you need to copy. I'm not going to tell you what to copy down and what to write and what to, use abbreviations for. But I will give you some guidance, a little bit of guidance. You have to know what a polygon is, and you have to be able to recognize it on sight. And you have to be able to explain why something is not a polygon or explain why something is a polygon. So, a polygon is a closed plane figure. Closed is important, plane is important. And it's formed by 3 or more line segments. So it can only be made up of line segments. So now I have a bunch of examples and non-examples. So you can see all the examples look pretty similar. It's just a matter of how many sides they have and how they're kind of configured. This one will become a little somewhat important later on. Bless you. Shapes that are not polygons. Let's see who's catching on. What's wrong with this one? What's wrong with that? Ania? Okay, what does it have? A curve. And that is a red flag right there, not a polygon. It must be all line segments. What about this one right here? What's wrong with that one? What's wrong with that one? Alicia?
It's open.
It's open. It's not closed completely. The other two are a little more difficult, but it's basically the same idea. This is considered open because of this extra extension here. Also, really, all the vertices are supposed to be connected to each other, and you can see that this vertex right here is not connected to any of the other ones. Also, every vertex is only supposed to have 2 lines connecting it, and this one has, right there, it has 4 lines, 4-line segments all converging on that one point. You could also say that that's somewhat open as well. What's wrong with this one? Looks like a polygon to me. Clearly very different. What's wrong with that one, Chris? You said that beautifully. I couldn't have said it any better. It exists in multiple planes. It's not in one plane. That's a hard idea that we haven't explored very much yet, but you will start exploring soon. Any comments, questions on what a polygon is? Okay, so again, I want to emphasize the fact that we are laying foundation. We are laying the groundwork for more complex ideas. We have to do this. It's going to seem simple to you. You're going to look at it like, okay, I get it, Mr. Gowd, I get it. But then all of a sudden it's going to shift. And you're going to see that now there's some more complex ideas. And we needed the time spent here so that they made sense. Are there any comments, questions on this? Good. So, you don't need to copy any of this, I don't think. This is all stuff you know, but it's leading to something. You already know a triangle, 3-sided polygon, quadrilateral, 4-sided polygon. This one will become extra important in a little while. What else do we know? Well, you knew most of this, but you may not have realized the terminology. Each segment is called the side. That's easy. But you may not have realized that each endpoint of the sides forms what is called a vertex. And when you refer to all of them, you refer to vertices. So you see this word vertices. So vertex, 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 vertex. Here's an idea that you may not have known already, the idea of a diagonal. A diagonal is formed by connecting any 2 non-consecutive vertices. That's a big boy word right there. Non-consecutive. Well, let's break it down. What does consecutive mean? Forget about the non. What does consecutive mean? Only one person has an idea? 2 people? 3 people? Tristan? Okay, that's on the right track.
Official?
Consecutive? Don't think official really plays into it, but I could be mistaken. And? In order? Next to each other. So consecutive would be like A and B are consecutive. They're right next to each other, in order. Okay? But non-consecutive would be not in order. So you can see that D and B are not next to each other, and you can form a diagonal. You can also form a diagonal from D to A. You could form one from E to B and E to C. But the diagonals are not actually part of the original figure. These are extra items that we will explore and that have different properties and actually do things to the polygon that you may not have realized. So you now have to be able to speak side of a polygon, vertex of a polygon, diagonal, consecutive, non-consecutive, vertices. All of these words, got to be fluent in them. Any questions?
Would you be able to do A to C since it's non-consecutive?
Yes, you should be able to do A to C. Thank you for pointing that out. A to C. Very good. Any other comments, questions? Okay, so now names. You have to know all of these names. Again, I'm pointing out the rule. You don't have to copy things you already know. Do you need to write down that a three-sided polygon is called a triangle? Probably not. But might you need to write down that a 12-sided figure is called a dodecagon? Yeah, you might need to write that down. So these are names based on the numbers of sides. So three-sided is triangle, four-sided quadrilateral, five-sided pentagon. I think we're okay with those three. You might even be okay with a hexagon being six-sided. But I think from there you might need to write some things down. Seven-sided is called a heptagon. Eight-sided, octagon. Nine-sided, here's an unusual one, a nonagon. 10-sided is decagon. 12-sided is dodecagon. Don't ask me why there's not an 11-sided, because I don't know the answer. And beyond that, it's referred to as an n-gon. Now, you don't say n-gon, you say whatever number of sides it is plus dash gon. So if you have a 30-sided shape, you would call it a 30-gon. If you have a 50-sided shape, you would call it a 50-gon. Any comments, questions? So again, you have to know all of these terms instantly off the top of your head. I'm going to give you a moment to copy what you need to copy. If you're done, maybe try to review the terms in your head and try to think about the terms that we've talked about already today, because there's more coming. In a moment, we're going to jump into some examples. The examples are simplistic. They're going to be quick. I'm not going to be spending much time on each screen. You copy what you need to copy. You do the best that you can. But all of it is important because it all lays the groundwork for what we're going to do in a little while. Are there any comments, questions? I have all this printed out on paper, so if you're missing anything, leave a little space and you'll fill it in a little while. So here we go. Example 1. For the first 3 examples, we're working on identifying whether or not something's a polygon, why, and what its name should be. So I'm showing you one picture at a time. This is the picture. The first question is it a polygon? If you think it is a polygon, you have to explain why it is. If you don't think it's a polygon, you have to be able to explain why you think it's not. And if it is a polygon, you need to know its name. So we're going to do some surveying first. Give you a moment to just copy what you need to copy. All right, give me a thumbs up if you think this is a polygon. Thumbs up if you think it's a polygon. Overwhelmingly, people think it is a polygon. And I will agree. Could someone put it into words as to why? Why is it a polygon? Janae? Very good. I love the way you described that. It's closed. It's made up of line segments and sides. Very good. So what should its name be? Since it is a polygon, what should its name be? Tristan? What is it? You sure? Good, you should be sure because it's a hexagon. So this is a polygon and its real name is hexagon. Anyone have any comments, questions, concerns? Good, let's keep going. What about this one? And again, you might want to sketch the picture, you might not, you may be feeling super confident. I leave it up to you. So, give me a thumbs up if you think this is a polygon. Some people think yes, some people not sure yet. Okay. Okay, Kayla, why do you think it is a polygon? Why is this a polygon? Good. Very good. Wow, that was a great explanation. So, we can definitely all agree that this is a polygon. What should its name be? What should its name be, Michaela?
Heptagon.
Davis, do you agree with that?
Yes.
Yeah, this is heptagon. Any comments, questions about this one? All right, what about this one? Give me a thumbs up if you think this is a polygon. Crickets. Nobody. Could someone explain why it's not a polygon? We got a whole bunch of people who can explain. Ania? As a curve. And a polygon must be made up of line segments only. So this is not a polygon. And since it's not a polygon, we do not give it a name, at least not one that we have available to us yet. Any comments or questions? Any concerns? Good. So now you try on your own. You do not have to copy anything. I need the answers to my questions. Checkpoint number 1. Tell whether it's a polygon, and if it is, name it. You've got 1 minute. It's still a shape. It's something important. It's just not. Okay, we're going to continue with the survey system. I don't think we need team talk for this. It's a little too basic. Part A, thumbs up if you think it's a polygon. Nobody thinks it's a polygon? It's good because it's not a polygon. Could someone explain why it's not? Why is it not a polygon, Ann? Okay, it's not closed. Very good. What about part B? Give me a thumbs up if you think that is a polygon. A lot of people think it is a polygon. It is a polygon. What should its name be? Marie? Zavari, you agree with that? Yeah, it is a nonagon. Very good. Any comments, questions, concerns on checkpoint number 1? Good, let's keep going. Now, here's where things are going to start building up. You got a lot more terminology in your head now, and I'm adding to it, and you're going to have to know all of it. Copy down what you need to copy down. It does not need to be in sentence form. It could be in little phrases, little arrows, a little diagram. I apologize for that. So, again, take notes however you want. A little diagram, a little arrows drawn from one word to another, whatever you need. But what you must know by the time you walk out this door is that equilateral refers to something, an object that has all the same length sides. They're all congruent. Equiangular refers to a shape that has congruent angles. A regular polygon is both equilateral and equiangular. So you have to know off the top of your head that regular, when we talk about polygons, means equilateral and equiangular. If a polygon is not regular, then it is called irregular. So now look at all the terminology that we've thrown in. Regular, irregular, equilateral, equiangular. Anyone have any comments or questions? Let's build from there. There are two other ways of classifying a polygon, and that is as concave or convex. You have to know both of these. Now, there's a technical definition, and then there's a way, I think, a simple way of remembering. So what it means is, what it's based on is, it's based on the diagonals. If a polygon has a diagonal that's on the outside of the shape, that's called concave. If all the diagonals are inside the shape only, that's called convex. So you can see this diagonal right here is on the outside of that shape, that's called concave. These diagonals are only on the inside, that's called convex. Now, concave, convex, the words are very similar. The first three letters are exactly the same. The words are almost the same length. They both have a letter V in them. They sound the same. So it's hard to remember which one's which. So I focus on cave. And not a cave as in a place where a bear hibernates, a cave as in something caving in. For example, a ceiling caving in would mean that the ceiling was coming in like this. So I see this as a ceiling caving in. And since it's caving in, that's concave. You don't have to remember what convex is, you just know that convex is the other one. Concave means caving in, convex is the other one. That's all you need to remember. But you have to know it off the top of your head, and you need to be able to describe a shape based on these two terms. Any questions about that? Good. So now let's put all of it together. So now we have this shape. This time, I'm not going to ask you if it's a polygon. I'm telling you it's a polygon. But now I want to know a few things. I want to know, is it regular or is it irregular? And then I want to know, is it concave or is it convex? So there's two pieces of information that I want to know. Give you a moment to do your own version of the picture. The first one's probably the most important, and then we'll go a little faster after that. So, you now need to also get used to pictures having all of the information that you need. So let's first get some opinions, whether or not you think it's regular or irregular. Give me a thumbs up if you think this is regular. Okay, we got 1, 2, 3, 4, 5, 6. Good, put your thumbs down. Give me a thumbs up if you think this is irregular. I got 1, 2, 3, 4, 5, 6, 7, 8. So kind of split, and then I've got a few people who didn't say anything. So where's my irregular people who think it's irregular? Brian, why do you think it's irregular?
Because for it to be regular, all angles must be equal to each other.
Okay, and these are not?
No, there are one pair of angles that are congruent and another pair that are congruent.
Very good. So that is the detail that you had to catch. Those two, since it's a single arc mark, those two are congruent to each other. But then, these two are congruent to each other because they have a double arc mark. And as he said, for it to be regular, it has to be equilateral and equiangular. Now, this is equilateral because of these marks right here. Those tick marks tell you that all of them are the same length. They are congruent. So it's equilateral but not equiangular, so that means it's irregular. Okay? Now we need to know if this is concave or convex. Is this concave or convex? Oh, we got some people who think they know. Jada, what do you think? Convex. Michaela, what were you going to say? Convex. Yeah, this is convex because there's nothing caving in, as I would say. Or technically, there's no diagonal that can be drawn on the outside. So let me show you what I mean by that. Let's start at this corner. Could I connect to any other corner by going outside the shape? Nope. 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 I can't, there's no way to get it to go, so this is convex. Does anyone have any questions about irregular convex? Anything at all? Good. So now we can go a little bit faster. What about this shape? First, I want to know whether it's regular or irregular. Regular or irregular? What do you think? Anita? You think it's irregular. Why? Let's use the new terminology that we're learning. It's not equilateral. Very good. Is it equiangular? It is. And I apologize because my projector doesn't project the colors properly, but these little lines right here are actual angle marks. All of them are supposed to be bright red, but it didn't come through. So those are right angle marks, and all of them, every angle has one of them in it, which means they're all 90 degrees. So her explanation was great. This is irregular. Okay, but what about concave versus convex? Is this concave or convex? What do you think, Catalina? Brandon, what did you think? This is concave because we can draw a diagonal from two vertices outside of the figure. In fact, we could do it a bunch of times. We could do it right here. Do it right here, and we can do it on the other side as well. Again, for me, just keeping things simple, I see this as something caving in, so I immediately knew that that's concave. Any questions about that? Yes? Can't be both. It cannot be both. It has to be one or the other. Now, if you're saying, if I just looked at part of the picture, like what if we just looked at that? That part of it looks like it's convex, but that's only part of the shape. Does that make sense? No? Still trying to understand concave versus convex? Okay, so the rule, you're right. We can write a line inside. But if I can draw at least one line outside, it immediately becomes concave. Okay? It's convex. All of them are inside. So thank you for pointing that out. So here, this is convex because all of the diagonals are inside. Here's one diagonal. Here's the other. There is no diagonal outside. That's it. That's convex. Okay? Thank you for pointing that out. Good. We're doing well. Don't copy this one. Just look. Is this regular, irregular, concave, or convex? This is a we do. Let's do it together. What do you think? Give me a thumbs up if you think this is regular. Thumbs up if you think it's regular. Fung, why is this regular? Use words that you learned today that you now have to become fluent in. You have to try. You can't say I can't say it when you haven't even tried. Very good. And? Very good. So you lied. You said you can't say it, but you actually said it perfectly. So this is a regular polygon because of exactly what Fung said, that these are equilateral and equiangular. What about concave versus convex? Give me a thumbs up if it's concave, in your opinion. So everyone thinks it's convex, and you would be correct. Convex. Any comments, questions, concerns on this? All right. Checkpoint number 2. You do not need to copy any of the text or any of the shapes. You just need to write the answers to my questions. You got 1 minute. All right. What'd you get for part A? A little bit of confidence. 1, 2, 3, 4, 5, 6. We got numbers 9, 14, and 23. Where's number 9? Where's number 14? And where's number 23? No number 23? That means it's Janae. Okay, go. What'd you get?
Regular and
Okay, what'd you get? What'd you get? It is regular and convex. Very good. What about part B? What'd you get? All right, we'll go Sebastian, Michaela, and Davis. Sebastian, what'd you get?
Irregular and concave.
Okay.
Irregular and concave. Irregular and concave.
All of you agree that it is irregular and concave. Give me a thumbs up if you got both of these correct. 100% correct. Good. Put your thumbs down. So we've got the groundwork done. We're comfortable. We got to start using the terms all the time. Now we build from there and solve some problems with these ideas. So now you're going to have to draw. You're going to have to draw a diagram. You don't have to write everything, but there's two parts to this, part A and B. And we can find some side lengths of some different polygons based on understanding the terms regular, irregular, convex, concave, equilateral, equiangular. Bless you. So this is a table. It's an actual picture of a table, and it's a regular hexagon. The expressions shown outside the shape represent the lengths of the sides. Find the length of a side. Give you a moment to set up something. All right, so there is something in the picture or the text that tells us exactly what to do. We're already being told what to do. And I'm not talking about the goal. I know what the goal is. The goal is to find the length of a side. But what to do to get that? There's something that tells us. What is it? 3 light bulbs went off? 4 light bulbs? A hesitant, semi-bright light bulb? Alyssa. Good. And what does that piece of information right there tell us? That's right. And because it's equilateral, what could we say about this and this? They would be the same. And so could someone tell us what we should do with these two expressions now? What should we do with them? Alicia? Set them equal to each other. Very good. Nicely done. 3x plus 6 equals 4x minus 2 because exactly what Alyssa said. It is equilateral. They are equal to each other. Solve for x. Takes just 1 or 2 steps to do that for my high-level students. Go ahead and do that. What does x come out to? Kelly? 7. Give me a thumbs up if you agree. Oh, we got a lot of dissension. Uh-oh. Check again. What do you think, Chris? X equals 8. Give me a thumbs up if you agree. Oh, we got more support for that. So it comes out to 8. Now, if I circle that and pat myself on the back, I just got the whole question wrong because what do I need to make sure I do? Danielle? Yeah, how do I do that? That's right. You have to now plug this in here, or you could plug it in here. You will get the same answer either way. 3 times 8 is 24, plus 6 is 30. 4 times 8 is 32, minus 2 is 30. No matter what, we get 30 inches. Make sure you put your units of measurement. Any comments or questions on how we accomplished our goal? Michaela, were you able to find?
Yeah.
Okay, so that's no big deal. That's a simple algebra thing that we can figure out. Comments, questions? All right, so now let's build from here. You can just write part B because it's the same picture. I just added in some new information. The expressions 8y degrees, and I made a mistake there. That should be parentheses. The expressions 8y degrees and 9y minus 15 degrees represent the measures of 2 of the angles. Find the measure of an angle. If you're having trouble conceptualizing, so we could put in 8y degrees there, and we could put in 9y minus 15 there. How come I could do this? How come I could take that and I could move it right there? How come I could do that? Jada? Equiangular. Okay, Very good. So they're all the same. So it actually doesn't matter where I put these expressions because they're all the same. But that also tells us what we're going to do. What are we going to do with this now? Brian, what were we going to do?
We're gonna set 8y and 9y minus 15.
Very good. 8y equals 9y minus 15. Solve the equation. So one step for my high-level students, maybe 2 steps. What does y equal? Kayla? What is it? Well, y comes out to 120? What does it come out to? 15. Very good. And then you went ahead and did what with the 15? Very good. So then you plugged it in here, or if you wanted to, you could plug it in there, and you get how many? 120 degrees. Make sure you put your degree symbol there. Any comments, questions, or concerns? Okay, nothing? Checkpoint number 3. You do not have to copy anything you don't want to copy. You got 2 minutes. Got 1 minute team talk. See how you guys did as a team.
Oh, I thought you meant
see how he did. We got teams B, C, and E. Where's team B? Team B. Ann, did everyone on your team agree? Okay, what did you get, Ann? Okay, Davis, what'd you get?
16.
Okay, Zabari? Okay, so we had disagreement here. What was the next group? C? Did your whole team agree? All agreed. Daniela, what was the answer you guys got? Okay, and you all agreed. And where's team E? Right here? Did you all agree?
Yeah.
Fang, what was the answer you all got? You all agreed to 16? The correct answer is 16 centimeters, and I love how Daniela pointed out the centimeters. Very good. So, for team B and any others, we need to help out our teammates and classmates. There was something that was a little intimidating when you first looked at this. What was the intimidating little feature that was thrown in all of a sudden? Tristan? Yeah, I looked at it, I was like, okay, what's going to happen now? And then someone tell us simply what happened when you actually do it. Maria? They just cancel each other out. They end up disappearing. And so in essence, you end up with the equation 6x equals negative 10x plus 32. And it actually ends up being fairly simple to find x. You get 16x equals 32, you get x equals 2, and then you just have to plug it back in. Okay? So was it that you made it more complicated than it really was? That the x squared was like throwing you off? Zabari? Oh, you wrote something wrong. Okay, and where did you have trouble? Okay. Do you? I mean, I didn't show how it gets canceled. Do you?
Well, I mean, like, instead of canceling them,
You added them together, but you see how it cancels? Okay, good. Any comments, questions, or concerns? Okay, draw a line across your paper. Your homework is on page 45. You are doing numbers 8 through 17, 28 to 30, 33 to 37, and number 39. That's 19 questions. You're going to do, as part of your review for the chapter, you're going to do online under the Student Resources tab. So that's after you log into My HRW. I've been telling you to go to the Videos and Activities tab, but under the Student Resources tab, there's something called the Interactive Practice Test. It's the first item on the list. Do the Interactive Practice Test, and now you'll have practice questions that are like similar to the ones you'll get on your actual test, but you will get feedback right when you're done. Okay? And your test, and here's where I got to figure some things out. So tomorrow is your long block. And Thursday is our short. So I'm going to say it's on Thursday. And we'll see how it goes. Maybe you'll be able to do it all in one short block. Maybe you won't, and I'll just figure it out from there.